Hello everyone. So welcome to Neo4j Introduction to GraphDB session. Today we are going to see how we can use GraphDB in our application. So today's agenda will be, in the next 40 minutes we are going to see what is GraphDB, why we should use Neo4j, the use cases, the Neo4j terminologies, and then we'll go for a demo session. So let's see what is Neo4j. Neo4j is an open source NoSQL native graph database. If you're coming from relational databases system, then you know nowadays we have SQL and NoSQL DBs, not only SQL DBs, where databases like key value pair, document based search engines. So there are a lot of new NoSQL DBs in which one category is graph database. So Neo4j comes into the category of native graph database. It's an open source NoSQL graph database that provides an ACID compliant transactional backend. Neo4j delivers the lightning fast read and write performance you need while still protecting your data integrity. It is the only enterprise strength graph database that combines native graph storage, its scalable architecture optimized for speed and compliance to ensure the predictability of relationship-based queries. So Neo4j is scalable, it's optimized for speed, and it supports ACID property. So let's see when we should use the right database for the right job. You are familiar with the relational database management system. Then we have discrete data and connected data. When we talk about discrete data, the unstructured, semi-structured kind of data, we go for NoSQL. And when we talk about relationship data, then we go for connected database. And the leader in the connected database or graph database ecosystem now, it's Neo4j is designed for data relationships, development benefits, and we also have deployment benefits. On development benefits, we have easy model maintenance and easy to query. On deployment, we have ultra high performance and minimum resource usage. Let's see the performance comparison between the SQL and the GraphDB. So when we compare Oracle Exadata versus Neo4j, you can see when we increase the number of nodes and the relations, you see the hike in the Oracle Exadata, whereas the Neo 4j is almost the linear. So Neo 4j is best for doing relationship based queries. Let's also see some statistics on performance comparison between RDMS and Neo 4j. So this we are doing on a data set of 10 lakh people. If you go for depth of 2, if you go for depth of 2, RDMS will take execution time of 0.016 second and Neo4j execution time will be 0.01. For the records returned will be approx 2500. At this phase you can see both the databases are giving the same execution time. But when we increase the level of depth, relational database will complete its execution in 30 seconds, whereas Neo4j will give the result in 0.168 seconds and it will return the records approx 1 lakh. So when we increase the number of depth in our query, relational database management system execution time increases exponentially. And Neo4j execution time is almost linear even if we increase the number of depth. So graph databases are in more places than you think. When it comes to current graph database technologies, Neo4j leads the industry as the most native when it comes to both graph storage and processing. Graph databases are extremely useful in understanding big data set in scenarios as diverse as logistic routes, optimization, retail suggestion engines, whether it's a fraud detection or social network monitoring. So let's see the comparison between relational database and a graph database. If you talk about data storage, on relational databases, we are storing the data in the form of tables. On Neo4j, we store with index-free adjacency results in faster transaction and processing for data relationship. So here we have index-free storage. If you go for data modeling, GraphDB provides a flexible data model. That means data types and sources can be added or changed at any time, leading to dramatically shorter development times and true agile iteration. If you talk about query performance, graph processing ensures zero latency, and real-time performance, regardless of the number of depth of relationship. But for the query performance on relational database, when we are increasing the depth of joins, we will suffer from the performance. So for the query language on relational we have SQL, and for GraphDB we have a Cipher query language. It's a native graph query language that provides most efficient and expressive way to describe relationship queries. Yes, both the DBs support ACID transaction property, so we can commit, rollback, processing at scale. Graph model inherently scales for pattern-based queries. Scale-out architecture maintains data integrity via replication. Massive scale-up possibilities with IBM Power 8 and CAPI flash system. So these systems, this GraphDB supports replication, and we can scale it. Scaling is also very easy. So data center efficiency, if you talk about on the graph database, the data and relationships are stored natively together with performance improving as complexity and scale grow. This leads to server consideration and incredibly efficient use of hardware. So let's see the comparison between NoSQL and graph database. So on data storage side, you know, NoSQL and graph database. Graph database native graph storage structure with index-free adjacency results in faster transaction and processing for data relationship. As you know, all NoSQL databases have their own pros and cons, and all NoSQL databases are made for their different benefits. So if you want to query for some relationship between the data, for relationship based queries, we should go for graph databases. And on graph databases, Neo4j is the leading native graph database. So let's see the graph category. In this graph, you can see we have all kinds of database management system, whether it's a relational database management system, time series, multi-value, object-oriented, key-value stores, search engine, document-based stores, wide column stores, or a graph database management system. You can see the popularity changes as per category. So nowadays, people are going for graph database management system. So let's see who are the customers of Neo4j and for what purpose they are using Neo4j. So you can see on social side, the companies like eHarmony, National Geography, Classmate, these are the companies who are using it for the social. For recommendation, e-commerce companies like Walmart, InfoJobs, these are using for the recommendation, search and discovery. So First Data, Lufthansa, these are the companies who are using Neo4j for search and discovery purpose. Networking data center, HP, NetApp, these companies are using it for the network and data center kind of requirements. So for master data management, Cisco, ADP, TechCrunch, these are the companies who are using Neo4j for their master data management. I&A, Identity and Access, Telenor, UBS. So you can see the multiple companies are using Neo4j for different kind of purpose, whether it's a recommendation system, a search and discovery, identity and access. So let's see how you can use Neo4j on your local. So to use Neo4j, you need to download Neo4j from neo4j.com/downloads. So when we compare relational versus graph, as you know, on relational databases, we have tables, and to connect multiple tables, we have foreign key, primary key, and to get the relationship between multiple tables, we need to join. But when the number of depth, when the number of join increases, it becomes slow. Whereas on the GraphDB, you can see all the nodes are in a flat structure, they are index free, they are easy to manipulate, and they are fast to search. So, are graphs everywhere? Yes, graphs are everywhere. Whether you talk about social network, network analysis, route finding, graphs are there. Whether you are using Google Maps, Uber, or any route finding application, graphs are there. Whether to find the shortest path. So graphs are also present for the recommendation, for getting friends of friend. On the logistic part, also graphs are present. So graphs are there. So graphs are everywhere. So let's see how the graphs look. On Neo4j, a graph data model looks like this, in which we have node, relationship, label. So in this data model, you can see we have four persons. First person is John Lee, then Len, Garam, and Ellen. So John Lee wrote a book whose title is Tinker, and that book is purchased by Ian on this date. So Ian has purchased two books, one written by John and one written by Graham. So graph enable us to query the relationship between multiple nodes. Suppose I want to get some information about how many person has purchased John Lee book. So we can easily query it using the cipher query language of Neo4j. So let's see the graph model. So there are four building blocks for Neo4j graph model. We have nodes, relationship, properties, and labels. So nodes, the objects in the graph, and it can have name value property, and node can be labeled. For relationship, it relate nodes by type and direction. So relationship can be directed or non-directed. We can have name value properties for our relationship. So here we have two person. A person Dan loves Anne, and the person Dan have a property like his when he is born, his Twitter handle, and person 2 and also have a property like when she is born. So there is a relationship between two that they both loves each other. Person A lives with person B, Dan lives with Annie, and Annie owns a car. Dan drives the car. The car node also have a property of brand and model. So let's see how we can use a cipher query language. At the bottom you can see, suppose we want to do some select query or get query. In cipher query language, we are using match keyword for that. So we have match, then give the label person and the property like what is the name of the person, give the relationship between and relationship with what node you want to get. The node 2 with the label person and the property. So let's see the nodes used to represent entities in your domain can contain properties used to represent entity attributes or metadata, you can say. It can be a timestamp, it can be name, date of birth, any metadata of that particular node. It's a key value pair. Every node can have different properties. So in this graph, you can see all the blue part, blue circles are nodes. So the next thing we have the relationship. Every relationship has a name and a direction, which adds a structure to the graph, provide semantic context for nodes. Relationship can contain properties used to represent quality or weight of relationship or metadata. Every relationship must have a start node and end node. So on this diagram you can see there is a relationship between two nodes. Like wrote is a relationship, purchased is a relationship, and purchased you can see it also have properties or metadata in the form of key value. So relationship can be nodes can have more than one relationship. Nodes can be connected by more than one relationship. Self relationships are allowed. So these are the multiple types of relationship which you can create between the nodes. You can give multiple relationship between nodes. You can also self relation to particular node. So relationships are defined with regard to node instances, not classes of nodes. Different nodes can be connected in different ways. Allows for structural variation in the domain. Contrast with relational schemas where foreign key relationship applies to all rows in a table. So these are the labels like person, book. These are the labels of particular node. So every node can have 0 or more labels attached to it, used to represent roles like user, product, company, group nodes. So label help us to group the node, allow us to associate indexes and constraint with groups of node. So now you know what are the four building blocks of GraphDB: relationship, properties, and label. So let's see how you can use Neo4j on your application. Suppose you want to connect Neo4j from your backend, which is written on Node.js, then you can install a library, a driver for Neo4j, that is npm install neo4j driver, and then you can use neo4j on your backend. So here you can see the JavaScript code, sample code for connecting your neo4j database and writing a query and getting the result from neo4j database. So in this code you can see on the first line neo4j.driver, we are giving the URI. The URI will be the address of your neo4j where it has been deployed. If you are running neo4j on your local, then you can use localhost. The by default port number is 7474. Or if you have installed neo4j on cloud, then the URL provided by the cloud platform. Then the username and the password for your neo4j database. Then you create a session using your driver. So on that session, you can write a transaction. So we have created a transaction tx.run. In inside run function, we can write the cipher code, the cipher query language. So we have written a cipher query here to create a label greeting and set a message. Whatever the message is passed, we will set and return a dot message from node, and it will return the message as hello world. So in this query, cipher query, we are creating a greeting, and that greeting is containing a message hello world. So when we execute this query or transaction, it will give us the result, and when we get the result, we can close the session and we can close the driver. Suppose we want to use Neo4j on our Python backend. Then for Python also it have a driver. So Neo4j provides driver for multiple languages like C Sharp, Go, Java, JavaScript, Python. In this example, we are seeing how we can use Neo4j on our Python backend. So for that, we can install the Neo4j driver of Python from pip install neo4j-driver. On our Python code, we need to give the URI, username and password for connecting the Neo4j database. We create a transaction of greeting and we will pass the cipher query for that. So by now, I think you understand how we can use Neo4j on our backend. It's like connecting the relational databases like SQL, Oracle, whatever you have used. So it's not different from that. So how we can use Neo4j? Neo4j we can use first by downloading it into our local system. Second option, they also provide Neo4j sandbox. So and it's free where you can go and try Neo4j online, and it also can be deployed on Neo4j in the cloud platform. So let's start our demo part. So let me show you what we can do on Neo4j. When we query for Neo4j on Google, we can get neo4j.com. So before going into that, let me tell you that Neo4j is open source software. It's written in Java and it was initial release date was 2007. So the current version of Neo4j is 3.5.8, which has been released on July 2019. Alright, now we are on neo4j.com. If you go to the product, on products, you can see they have a Neo4j graph platform where they provide Neo4j database, Aura database as a service, where the Neo4j company is providing DB as a service on cloud. Then we have Neo4j desktop. That means you can download the Neo4j in your own laptop or PC and you can use Neo4j for the development purpose. Then we have Neo4j Bloom, Neo4j Graph Analytics, and Cipher Query Language. So on the solution part, you can see Neo4j can be used for artificial intelligence, fraud detection, identity and access management, knowledge graph, master data management, network and IT operation, privacy, risk and compliance, real-time recommendation, and set social networking kind of use cases. On our previous slide, we have also seen what are the companies and for what use case they are using Neo4j. So you already know that big companies like Walmart, eBay, NASA, UBS, these are the companies who are using Neo4j on their products, on their projects. Okay, so let's go into Neo4j. If you go to products, get Neo4j, then for this demo, I am going to show you how you can use Neo4j sandbox. So you can use Neo4j online for free. So this is how when you go to the sandbox, it looks like this. Or I will show you how you can go to products, get Neo4j, try Neo4j online, click that. It will ask you to log in. You can log in from your account, create an account. Here, after creating an account, you can see, so we have Bloom Visual Discovery. So Bloom is also a product from Neo4j. Then you have multiple examples of DBs or use cases which you can try on Neo4j sandbox. Suppose you want to go for crime investigation. So this will contain the data of crime data like uh, police person, object location, event, model in public database from Manchester, UK. So it's a sample database of crime reports. Then Women World Cup data you have, Russian tutor polls, network IT, graph algorithm. So there are the multiple or use cases or data types, databases you have, which in that database you can try your Neo4j. So I'm going for this one, crime investigation. Click on the launch sandbox. So it is starting a new Neo4j instance for that. So meanwhile, it's spinning up a server, Neo4j server for you. So I already have opened some sandbox which have a database of movies. So it's a sample database for movies. Okay, so when you open the sandbox, it will look like this. Your queries, you can write it here. The connection URL is given here. You are connected as a user Neo4j. By default, user is Neo4j. So here I am running the Neo4j server 3.5.11, which is enterprise version. So let's see the different kind of queries we can write on Neo4j. So first we will start from creating a node. To create a node, you can use create keyword for that or create clause for that. We'll give the label of a person and we will define his property like name, from where. So let's go into Neo4j. I will paste my cipher query here and I will click the play button. So it's saying that added one label, created one node, set three properties, completed after 1 millisecond. So we have successfully created a node with person. So for select query, there is a match cipher query for that. I will paste that match person is a label and where the person name is Emil. So let's try this. So it's not a good query. Okay, let me try the different query. So this query will create nodes and add relationship. So let me copy this one and paste it on the query box. Okay. So when I run that query, so it had successfully created 8 labels and 8 nodes and set 28 properties and created 14 relationship. So let me show you what query I have written here. So on the first line I have written match person, where for person I have given a EE double E, where EE dot name equals to Emil. Then create another person JS with this property where the name is Johan, he's from Sweden. Then create another person Ian, another person Rick, another person Ellie, Allison. So like this I have created about 4 new persons here, or 4 new nodes. Then I have given a relationship like EE knows. So the thing on the square bracket is a relationship. This on this line, if you can see. So EE is the first person that we have matched, Emil. So Emil knows since we can since 2011 2001 is the property of this knows relationship. Then we give a arrow like direction that this person knows JS. Then EE also knows IR, JS knows IR, and JS knows RVB. So like this I have a given the relationship between multiple person, that who knows who. So when we run this query, we have successfully created our nodes and relationship. So for select we have match query on Neo4j. So let me clear this one and paste the new query for match. Let's see if we are able to find email. Yes, we can find it. So for finding the email person, I have written a match query. I have given EE. You can give any keyword here. It can be XYZ, and use that one to give the property. So this person have a property name and we are matching that name is Emil. If the name is Emil, then return the EE. So we have 2 persons with the name Emil. So 2 entities we got in the response. So this data we can visualize in graph form, in the tabular form, in the text form like this. On code you can see when we ran this query, match query, we got the response in the form of array, a JSON array, in which we got the identity, labels, property of that person, So this information which we are getting inside the fields, you can use while creating your backend. If you are familiar with the Elasticsearch or MongoDB, you know that the response we get from the NoSQL DBs are in the form of JSON or JSON array. So like same on Neo4j also, we get the response in the form of JSON array. So for creating, we use create clause. For selecting, we use match clause. So you can create the relationship between two unrelated nodes. Like in this query, you can see it. Let me zoom. So on this query, what we are doing, we are doing a match on and m, where n.name is Allison and m.name is Emil. Then we create a relation of knows, that n knows m, and we have given a direction. So while creating a relationship, we can give the direction. So let's try to run this query on our Neo4j sandbox. So we have created a relationship. So we can also create a node with multiple labels, like a person can be an actor or director. So multiple nodes can be assigned. Sorry, multiple labels can be assigned into a particular node. Okay, now we will see how we can update our database. So for updating, first we need to match n, where n.name is Rick, and set a new property owns Audi. So let's see if we have a name with Nick. All right. So we have successfully created three properties. So what we did, we have taken Rick and we have added a new property on his node as he owns Audi. Okay. In this example, you can see I have written a match query where I am selecting all the persons by the limit of 25. So here I am getting all the persons, which all the nodes I have created, and I have also given the knows relationship between all persons, like Nick knows Allison, Allison knows Emil, Emil knows Johan. So this relationship we can see. So using the graph Neo4j graph UI, you can visualize this relationship on a graph. You can also see this in the form of tables. So all the persons we can see here, Emil, John, Rick. On Rick, we have added a new property owns, that you can see here. in the textual form you can see. So this is how the graph QL, sorry, this is how the graph DB help us to visualize our relationship between the nodes. So for deleting, what we can do to delete, we are using delete clause for that. So in this query, we are matching n which have a relation with blank means any node where id n equal to 5 and delete both relation and the n. N is the node. So what will it will do? It will delete the id 5 and its relationship. To delete multiple nodes, we can write id of n in 1 2 3. So it will delete all the nodes with the id 1 2 3. Delete a property in a specific node. So we will do a match query, match n, where n person and n dot name is Rick and n dot place is not null. Then remove the n dot place. So this is how we remove the particular property of any particular nodes. So here you can see we can use n dot place is not null and exist n dot place. We can use and or operation for that in our where clause. We can delete all the labels like match and remove n dot person. It will remove all the persons. So for deleting we use a remove clause. So now you understand how we can use the CRUD operation on our Neo4j database and how you can write the cipher query language. So this thing we are trying on our Neo4j sandbox, which is provided by neo4j.com. You can also download Neo4j on your local system and try this on your system. So here you can see we have nodes, how many nodes we have, the relationship type, so on this relationship I have written a query that any node which have a relation of acted in, return that. So it has written me all the nodes which have a relation of acted in. For properties, you can see I have written countries, so it will give all the properties, all the countries, you can see it here. If I will search for name, it will give all the names of the node. So on this you can also do distinct search, union all. So all these things are possible on cipher query language. So let's see what else we can do. So you can also create an index using the create index on what label you want and what property. You can also create a unique constraint on your label name and property name. So this is how you create a node and a relationship. It's a hello world query. So in this query, we have created a database node with a property Neo4j, which have a relationship of says, and we created another node message, which have a property of hello world. Then we return that node database message and R. So this is the hello world program, hello world cipher query. You can see. So if you want to do the data profiling, so there here are the examples to count all how many nodes we have on our GraphDB. So it has written me that this 32,000 nodes I have on my GraphDB. Then how many relationships do I have? So it will count all the relationships between every node. Then what kind of nodes exist? So you can see we have movies, label, user, person, how many average property count they have, the minimum property count, maximum property count, average relationship count. So all this thing you can do using the data profiling cipher query. What is related and how? So when we call DB schema, you can see on schema we have a director, movie database we have, then we have a person database. So these are the different kind of nodes we have on our system, so that we can get using the call DB schema. So call db.labels, what it will give? It will give all the kinds of labels we have. List relationship types. So these are the relationships we have, like acted, indirected, knows, says. So here are the schemas we have. On indexes on we have movies, actor, director, then constant we have. So let's see the common procedures which we have on Neo4j. So when we call dbms.procedures, it will give all the kinds of procedures which we have on Neo4j. List functions. So this will return all kind of functions which we have here. So you can visualize it in tabular form or text form. So I think now you got overall of understanding how you can use Neo4j. What is Neo4j? How the graph DB we can use. All kind of basic ideas I think now you have. So thank you for attending this session. We'll meet again on our next session on next weekend. Thank you for joining. Have a great day. See you.